Next, we're going to create the ceiling recess light material. Open the material editor, select a new material slot and name it as Ceiling Lights. Apply a new V-Ray material as previously done. In the diffuse toggle, apply the bitmap named floodlight.jpg. Change the selection type to All and select the recessed light object in the ceiling. Isolate and open the group. As you select the light object, you'll notice that there's already a UVW modifier applied to it, with the cylindrical and cap option enabled. Assign the bitmap. The following step is to change the color to yellowish to emulate as if the light is turned on. Expand the output rollout parameters and switch on the Enable Color Map option. Also, enable the RGB option. By default, the R, G and B buttons are enabled. Unclick the G and B buttons and leave the R enabled. To move it individually, click on the top point of the red curve and move it upwards. Notice how the rectangular bar below is gradually changing to red. Enable the green button and begin moving it down to change the color. Now both red and green colors are mixed. Next, enable the blue button. Now that all these three colors have their button display, begin moving the points to achieve the yellow color. Once satisfied with the yellow color, go back to the main V-Ray parameters. Copy the diffuse bitmap and paste instance it in the self-illumination toggle. Also, set the multiplier value to about 7.0. Exit the isolation mode. The remaining materials in the scene were created using some of the techniques highlighted earlier. The final scene ended up looking like this. Let's do another test render to check the overall scene. The overall scene is now coming together very nicely. When we zoom in, you can see the curtain being reflected on the glass of the picture there, and the IES light pattern here, and the kitchen lights around the back wall. It's good practice to have balanced renders, so you don't end up with areas that are too bright or too dark. This will later give you the flexibility to add curves in post with great ease and improve the image dramatically. The following step is to show how to create proxies when you have heavy objects in the scene, such as these sofas. Proxies often help users navigate through the heavy scenes and render complex objects very fast. Before converting objects to proxies, make sure to attach the relevant objects first. To create a proxy, select the sofa first. Right-click and choose the V-Ray Mesh Export. In the V-Ray Mesh Export dialog, you have the first option, which is the folder. This function allows users to set the location of where the proxy mesh will be saved into. To set the location, simply click on a browse toggle and choose the location to save the V-Ray mesh. The file location allows users to rename the selected object in the scene. By default, it uses the name of the selected object in the scene, plus the file extension .vraymesh. Next, enable the function to automatically create proxies and press OK. As you can see, a proxy of the sofa was automatically created. Also, the name V-Ray proxy was automatically added before the original name. Open the Modify panel to check the proxy settings. In the Mesh File section, you can see the location link where the mesh file was saved into, and by clicking on the Browse button. The Scale function allows users to scale the proxy object up or down if and when necessary. The value of 1.0 is often OK. In Display Group, you have many options. By default, the display is set to Preview File Faces. However, you can set the display mode to bounding box, preview from files, preview from file faces, point, and show whole mesh. You can also choose to import as mesh if you want to make changes to the mesh. The remaining settings are pretty much self-explanatory. When copying proxies, make sure they are instances as opposed to copies, otherwise your images will take longer to render. Next, we're going to set up the V-Ray multimat and the material IDs. Let's start by opening the material editor first. Select a new material slot and pick the sofa material with the material picker. Next, open the Render Setup dialog. Open the Render Elements tab and click on the Add toggle. Choose the multimat element and OK to close the dialog. In the multimat element parameters, we have the R, G, and B colors. They're set as materials 1, 2, and 3. When rendered, one of the elements will look like this. These are the red, blue, and green multimat colors. When selecting elements in post-production, film studios and most companies prefer multimat render elements over wire colors because the selection is 100% accurate. Also, because it picks up selections on reflections, refractions, and other effects. By not having the EASE material ID enabled, V-Ray is automatically looking at the object ID numbers in the scene. To set up the object ID, simply select an object in the scene and right-click. Choose the object properties from the quad menu list. In the Object Properties dialog, under General tab, type in any number in the gbuffer object ID. So if the floor object is ID 1, you can select another object with a different material in the scene and set it to a different object ID number. If you need more than 3 object ID numbers, you would need to rename this first one, add a new multimat element, and rename it. Also, you'd need to type in a different ID number for the second multimat element. For objects or attached objects with multi-sub-object material on, you'd need to enable the EASE material ID option here. Once this option is enabled, this multimat element will be looking at material IDs instead. To set up material ID, simply go inside a multi-sub-object material, click on the material ID button and hold. As you can see, material IDs are restricted to 15 numbers, and this one is set to material ID 8. When using multimat elements as material IDs, for reference purposes, you'd normally rename the multimat element as _sub1 and change the RGB numbers according to the material IDs. Refer to the final 3ds Max file to see how the multimat was set up. Next, we're going to set up the V-Ray Light Select elements. When rendered, a V-Ray Light Select element will look something similar to this. This render element helps users control the light intensity and color in post. To set this render element, click Add and choose the V-Ray Light Select element from the list. Once loaded, click Add and select one light in the viewport. V-Ray Light Select element works best with one light per render element. This will allow you to control each light individually in post. Make sure each V-Ray Light Select element is named differently. Because we have quite a few lights in the scene, to expedite this process, we're going to use a script called Auto Render Element V-Ray Light Select. This script automatically adds V-Ray Light Select element for every single light in a scene individually. For more information on how to find this script and install it, please check my blog, YouTube channel or Patreon page. The video is called 3ds Max Forest Pack Roll Clone and V-Ray Light Select Script Tutorial. To start, click the script button from the toolbar. In each dialog, you can choose the current selection or all lights in the scene. To create the render elements with lights, simply click on Create Elements button. You can see all V-Ray Light Select elements being created automatically. Also, you can see every render element was named accordingly. The next step is to start setting up the high resolution renders to test the overall quality before sending the final render. Open the Command tab and set the render output size to 4,500 pixels by 2,601 pixels. Next, open the V-Ray tab. Under Bucket Image Sampler, for universal workflow, let's set the max subdivision to 100. This way, you'll be able to control the render quality with the noise threshold and the minimum shading rate values. To decrease the noise appearance and increase the quality on renders, reduce the noise threshold to about 0.003. Reducing this value increases the rendering time substantially. Also, under Image Sampler, increase the minimum shading rate value to about 12. Increasing this value increases the rendering quality without affecting the rendering times. Back in the Command tab, let's set the area to render as region and adjust the region area in a viewport. Next, open the Render Elements tab and begin adding crucial render elements such as V-Ray Alpha, V-Ray Diffuse Filter, V-Ray DRB Bucket, V-Ray Global Illumination, and so on. Refer to the final 3ds Max and the PSD files to see what was used. Once all elements are loaded, do a quick region render. The overall quality is looking good now. Let's go through some of the render elements to see if everything is looking smooth. The V-Ray Sunlight Select is looking good. If you look closer on top right hand corner, you'll notice a bit of noise there. Let's check the window V-Ray Light Select. It does look a bit noisy. Let's cancel the render and tweak some of the settings. Back in the V-Ray tab, let's increase the minimum subdivisions to 4. Change the render elements display to V-Ray Light window and do another test render. As you can see, the noise has disappeared mostly. The following step is to begin increasing the remaining settings before sending the final render. Cancel the render and open the GI tab. In the ambient occlusion parameters, increase the subdivisions to about 24. Under current preset, set it to medium. Under Light Cache, increase the subdivisions to about 1500. Open Command tab and change the area to render to view. Open the V-Ray tab and enable the V-Ray raw image file. This file format is a backup in case the file suddenly crashes. You can choose file formats such as V-Ray image file, deep EXR and EXR. Click on its toggle to set the location and name it. Let's name the raw file as Interior Apartment Daylight. Enable all 3 file formats. Also, enable the separate render channels, save RGB and alpha options. Click on its toggle and name it as before. Save the file type as TIFF. Click on the Setup button, choose the 16-bit color image type and set it to 300 dpi, dots per inch. Click Save. Also, enable the resumable rendering option. This is one of the best V-Ray features. This function allows the renders to restart exactly from where the last packet was rendered, even if the render crashed accidentally. So for instance, if you needed to stop a render, switch off the computer and continue the following day, you can. only the pre-calculation process would be recomputed, but the actual render would start from where the last bucket was saved. This function should only be enabled when sending the final renders, and you can only resume a render if you have this function enabled before starting the render. Before sending your final renders, save one or more of your previous test renders. Open them in post to see if the gamma looks exactly as you see in a frame buffer. If the gamma looked darker, then you would need to enable the gamma settings in 3ds Max. Simply go to Customize toolbar and choose Preferences. Open the gamma LUT and set it to 2.2. Next, go to the frame buffer and choose to save multiple. When saving it, name the file, choose to override, set the correct gamma value and save it again. After saving, open it again in post to see if the gamma is coherent with the wireframe buffer. It's very prudent to do these tests before sending out the final renders. The final render should look similar to this one. I really hope this course was helpful to you. The follow-up course will take you through the process of turning this raw render into this one. I'm really excited to show you how.